Observe the battery of this car. What do you notice? Yes, there is corrosion at the terminals of the battery. Can you guess what is causing the corrosion at the terminals of the battery? Corrosion at the terminal of the battery is caused by the reaction between sulfuric acid from inside the battery with the metal clamp. As you can see, this reaction produces white salt deposits on the clamp and the terminal. At the end of this lesson, students should be able to describe the preparation of soluble salts using the reaction of an acid and metal. Write chemical and ionic equations for reactions used in the preparation of salts.
Now prepare zinc sulfate salt. You are given some zinc powder. Can you suggest the name of an acid needed to prepare the salt? Select the acid and put it on the table to start the experiment. Incorrect. Try again. Yes, you are right. We need zinc and dilute sulfuric acid to prepare zinc sulfate. First, measure 100 cubic centimeters of 1.0 moles per cubic decimeter of sulfuric acid in a measuring cylinder. Pour the acid into a 250 mm beaker. Using a spatula, add approximately 5 grams of zinc powder into the acid in the beaker. What can you observe when zinc is dissolved in the acid? Do you see bubbles of colorless gas produced? Can you name the gas? Key in your answer in the box and click on the check button when you have finished. Good! The gas evolved is hydrogen gas. Stir with a glass rod until the zinc powder can no longer dissolve in the acid. When zinc has completely reacted with sulfuric acid, can you name the soluble salt that is formed in the solution? Key in your answer in the box. Click on the check button when you have finished. Incorrect. Please try again. The solution formed is a solution of zinc sulfate salt, but there is still some excess zinc powder in the solution. How do we remove the excess zinc powder? Let's see how it is done. Filter the zinc sulfate solution using a folded filter paper placed over a filter funnel. Why is this process necessary? Filtration helps to remove any impurities and excess zinc powder from the zinc sulfate solution. These impurities will remain on the filter paper as residue. The filtrate zinc sulfate solution is poured into an evaporating dish. It is then heated gently over a Bunsen burner until it is 1/3 of its original volume. This is to make the solution saturated. Leave it to cool at room temperature. What do you observe? There are some white crystals formed in the evaporating dish. Now, can you name these crystals? Key in your answer in the box and click on the check button when you have finished. Incorrect. Please try again. These are zinc sulfate crystals. Next, filter the content of the evaporating dish to separate the crystals from the solution. Wash the crystals with a little distilled water to further remove any impurities. Lastly, dry the washed crystals using filter paper or a desiccator.
Let us observe a part of the video from the previous experiment on the reaction of zinc and sulfuric acid.
From this animation, we are going to learn how to write a chemical and ionic equation for the reaction in the preparation of zinc sulfate. Given the formula for sulfuric acid and zinc, now can you complete the equation? What products do you think will be produced? Key in your answer in the table and click on the check button when you have finished. Incorrect. Try again. The products are zinc sulfate and hydrogen gas.
When we write a chemical equation, first we have to write the correct formulae for the reactants and products. Do you think the chemical equation is balanced? If it is not balanced, adjust the coefficients.
Let's see. Well, it is balanced. Now, we're going to write an ionic equation based on the chemical equation.
We'll write down all the formulae for the ions present in the reactants.
Look at the reactants. The ions present in sulfuric acid are hydrogen ions and sulfate ions. Now let's look at the products. The ions present in zinc sulfate are zinc ions and sulfate ions. Hydrogen gas has no ions because hydrogen gas is a molecule. Key in the ions formula in the table to complete the ionic equation and click on the check button when you have finished. Incorrect. Try again. Now look at the ionic equations. Are there any spectator ions on both sides of the equation? We're now going to cancel out the spectator ions to get the final ionic equation. Finally, the net ionic equation for the reaction is obtained.
We're now in the land of the long, long lost Egypt. In this lesson, we have learned that most reactive metals react with acids to form soluble salts and hydrogen gas. A salt is formed when the hydrogen ion from an acid is replaced by a metal ion. Soluble salts can be prepared in the laboratory based on the following steps. First, a reactive metal reacts with an acid. Next, the salt solution formed is filtered to remove excess metal. The filtered solution is then evaporated to make it saturated. The saturated solution is cooled to form crystals. Then the crystals formed are washed with a little distilled water. After that, the crystals are dried using filter papers or a desiccator. When a salt is formed from the reaction between a reactive metal and an acid, different types of equations can be written. For example, reaction between zinc and sulfuric acid will produce zinc sulfate and hydrogen gas. As for the ionic equation, write all the ions and molecules present on both sides of the chemical equation. As for the net ionic equation, any similar ions from both sides of the ionic equation will be cancelled out. When salts are dissolved in water, they give different pH values. Observe this animation. Each of the salts will be added in the water, and their pH values are measured. We are going to record the pH meter readings in the table. Now, look at the table given. It shows the salt preparation method and pH values of their solutions. Can you explain why the pH values of the salt solutions are different, even though they are prepared using the same method? Find out more and present your findings in the class.